Hello everyone, this is the challenge question walkthrough for Edexcel's Pure Year 1 textbook review exercise 3. Okay, our first question. The position vector of a moving object is given by cos theta I plus sin theta j, where 0 is less than or equal to theta is less than or equal to 90 degrees. And part A asks us to find the value of theta when the object has a bearing of 90 degrees from the origin. So, if we draw the origin here, a bearing of 90 degrees from the origin, if we look at the north line here, when the object is at a bearing of 90 degrees, it will be somewhere on this line here. Okay. Now, we know that the j component, so the vertical component of any vector on this line, is going to be equal to 0. So we know that sine of theta must be equal to 0. So theta is equal to 0 degrees. Because remember, we must have it between 0 and 90. Okay, for part B, we're asked to calculate the magnitude of the position vector. So if we plug theta equals 0 in, we get cos of 0, which is 1 lot of I, and then 0 lots of j. So the magnitude of this vector is just going to be 1. And our second question, the graph of the cubic function y equals f of x has turning points at minus 376 and 2 minus 49. And for part A, we're asked to show that the derivative of f of x is equal to k lots of x squared plus x minus 6, where k is a constant. And part B asks us to express f of x in this form, where a, b, c, and d are real constants to be found. So we know that at turning points, we must have that the derivative is equal to 0. So we must have that f dash of minus 3 is equal to 0, and f dash of 2 is also equal to 0. Now we can use the factor theorem here. If we know that f dash of minus 3 equals 0 and f dash of 2 is equal to 0, then we know that x plus 3 and x minus 2 must be factors of the derivative of f of x. Therefore, we must have that the derivative is equal to a constant lot of x plus 3 times x minus 2. And if we expand the brackets there, we get x squared plus x minus 6. Now for part B, we're asked to express f of x as a cubic. So if we know that the derivative is equal to k lots of x squared plus x minus 6, then if we integrate, we will get f of x. So f of x is equal to the integral of k lots of x squared plus x minus 6 dx. Now if we take the k out as a constant, that will make our lives easier when we integrate. So this is going to be equal to k lots of, so we have 1/3 x cubed plus 1/2 x squared minus 6x, and then plus c. Now here we have two constants which we need to find, the k and the c. And to do this, we can use the 2 points that they've given us that we know are on the curve. So if we first use minus 376, then we have 76, the y value is equal to k lots of 1/3 times minus 3 all cubed, plus 1/2 times minus 3 all squared, minus 6 times minus 3, plus c. And now if we simplify things a bit in the bracket there, we have first of all minus 9, then plus 9/2, plus 18, plus c. And so we have 76 is equal to k lots of 27/2 plus c. And now if we do the same with the point 2 minus 49, we have minus 49 is equal to k lots of 1/3 times 2 cubed plus 1/2 times 2 squared minus 6 lots of 2 plus c. And so again, simplifying the inside of the bracket there, we have 8/3 plus 2 minus 12 plus c. So we have minus 49 is equal to k lots of 8 thirds minus 10, which is minus 22 thirds, plus c. Okay, and now if we take these two equations in terms of k and c, we can solve them simultaneously. And it might help if we expand the brackets first. So here we have 76 is equal to 27 halves lots of k plus k lots of c. And then down here we've got minus 49 is equal to minus 22 thirds lots of k plus k lots of c. Now if we call this equation 1 up here and this down here equation 2, and if we take them away from each other, so the top equation take away the bottom equation, then we get 76 minus 49, so that gives us 125. It's equal to 27 halves k plus 22 thirds k. So that gives us 125 over 6 lots of k, and the kc's cancel. So we have that k is equal to 6. Now if we plug back in to find the value of c, let's use equation 1. Then we get 76 is equal to 6 lots of 27 halves plus c. So we have that c is equal to 76 over 6 minus 27 halves, which gives us minus 5/6. So remembering from earlier, we had f of x is equal to k lots of 1/3 x cubed plus a half x squared minus 6x plus c. Then we have, using our values of k and c, that f of x is equal to 6 lots of 1/3 x cubed plus a half x squared minus 6x minus 5/6. And multiplying through by the 6, we have 2x cubed plus 3x squared minus 36x minus 5. And that's in the form that they require. Right, our third question. Given that the integral from 0 to 9 of f of x dx is equal to 24.2, state the value of the integral from 0 to 9 of f of x plus 3 dx. Okay, so if we imagine what this integral here looks like, so let's draw some axes. Let's imagine the curve looks something like this. Okay, and let's say the point where x equals 9 is here. Okay, and so this area here is the 24.2. Okay, now if we imagine what the integral that they're asking for looks like, so f of x plus 3, then the graph of f of x will just be translated upwards by 3 units. So instead it will look something like this, where everything's moved up by 3. So the point 9 is still in the same place here, and our area from before is still here. But now we've got this extra little rectangle at the bottom, which we need to add to the integral. And the area of this little extra bit here, well, we know that the height of the rectangle is going to be 3, because that's how much we move the curve upwards. And we know that the width is 9. So the area of this extra little rectangle here is just 3 times 9, which is 27. So we know that the value of the integral from 0 to 9 of f of x plus 3 dx is going to be equal to 24.2 plus 27, which is 51.2. And another way of thinking about this is to actually evaluate the integral of f of x plus 3, keeping f of x as it is from 0 to 9. So this is just going to be equal to the integral from 0 to 9 of f of x. And then splitting the integral, we need to add on the integral from 0 to 9 of 3 dx. And this here will give you your 24.2. And then 3 integrates to 3x from 0 to 9, and that will give you your 27. So there's 2 ways of thinking about this question for you. And finally, question 4, the functions f and g are defined as f of x equals x cubed minus kx plus 1, where k is a constant, and g of x equals e to the power of 2x, where x is a real number. The graphs of y equals f of x and y equals g of x intersect at the point P, where x equals 0, and part A asks us to confirm that f of 0 equals g of 0, and hence state the coordinates of P. So, just evaluating f of 0 and g of 0. F of 0 is equal to 0 cubed minus k lots of 0 plus 1, which is equal to just 1. And then g of 0 is equal to e to the power of 0, which is also equal to 1. So f of 0 equals g of 0, as required. Now, they also ask us to find the coordinates of P, and P is a point of intersection. So we know that when we plug in x equals 0 into both f of x and g of x, they both give you 1. So the point of intersection P has coordinates 0, 1. Now for part B, given that the tangents of the graphs at P are perpendicular, find the value of k. So for this, we need to differentiate. So firstly, differentiating f of x, we get 3x squared minus k, and doing the same for g of x, we get 2e to the power of 2x using the chain rule. Now, to find the gradient of the tangent for each of the curves, we just need to substitute x equals 0 in. So f dash of 0 is equal to 3 times 0 squared, so that's 0 minus k. And g dash of 0 is equal to 2 times e to the power of 0, so that's just 2. Now, we know that these gradients are perpendicular, so minus k must be equal to minus a half, so k is equal to a half. And that is the end of review exercise 3. I hope you enjoyed the video, and I'll see you next time.